Okay, this is 7.4, rational exponents. Okay, before we start rational, okay, you have to look at the root of the word, which is ratio. So we're looking at exponents that are fractions. Okay, and a quick review, if we have a to the negative n, so a base raised to a negative exponent, that means we have to move it to the denominator of our fraction. So now it is 1 over a to the n. Same if we had 1 over a to the negative n, so we'd want to switch it from being in the denominator to being in the numerator. Okay, so the rational exponents we're looking at are a to the x over y. Okay, so our x is going to be our exponent like normal. It always is going to stay with our a. And then our y is going to be our index. Now remember, an index is what goes in front of our radical. It tells us whether it's a square root, a cube root, a fourth root, and so on. So our basic form would be a to the x over y. And then we can change that into our radical form. Again, we put that y, our index, outside of our radical, and our exponent stays inside with our a. We also can write it a different way. Instead of putting that x on the inside, we can raise it to the exponent last. So using our order of operations, we'd take care of our radical on the inside, and then whatever we got for that answer, we would raise it to our exponent. So our new form we have is exponential form, and then the other two are both radical forms. And we're going to be switching back and forth between the two. Okay, first one, we want to write each of our problems in radical form. So number one, we have x to the 2/7. Our 2 is on top, so it's our exponent. Our 7 is on bottom, so it's our index. So we're going to take the 7th root of x squared. Okay, now let's look at number 2. So now we have AB in parentheses raised to the 2/3. Okay, so since we have A and B in the parentheses together, they're both being raised to the 2/3, so we have to keep them together. Okay, so the 3 is on the bottom. Okay, it's in our denominator, so it's going to be our index. So we're going to take the cube root, and then we keep that A and B in parentheses, so that we raise the whole thing to the 2nd power. Okay, so we're squaring the whole thing. Number 3, we have 2x to the 1/2. Okay, so notice here that we don't have parentheses, so the 2 does not have the power of the 1/2. So we're going to keep the 2 outside of our radical, and then since we have a 2 in our denominator of our rational exponent, that's going to be our index. So we have 2 times the square root of x to the 1st. Now we're going to do a little simplifying here, because if we go ahead and drop the 2 outside of our radical, our index, it's always assumed to have an index of 2, so it's unnecessary. As well as the 1 as the exponent. That is also unnecessary. So we rewrite it as 2 times the square root of x. Number 4, we have y to the negative 0.4. Okay, so we need to fix that negative first. Back in the beginning, we talked about negative exponents. So if we wrote y to the negative 0.4 as a fraction, we'd put it over 1. So we want to change that into 1 over y to the 0.4. Okay, so we always fix it to be positive, and then we take our next step. So we've been looking at rational exponents, and right now we have a decimal. So if we change that 4/10 into a fraction, we get 1 over y to the 2/5. Now we can put it in radical form. So the top, we have a 2. That's going to be our exponent, and on the bottom we have a 5, so that's going to be our index. So we have 1 over the 5th root of y squared. Okay, second section, we are going to write it in exponential form. So we're doing the opposite of the last section. So number one, we started with the fourth root of c to the fifth. Okay, so the 5 is our exponent, so it's going to stay in the numerator, or the top of our fraction, and our index, which is 4, is going to be on the bottom. So when we rewrite it as our rational exponent, we have c to the 5/4. Number 2, we have the cube root of x squared. Okay, so again, our exponent is a 2, with our index being a 3. So when we rewrite it, we have x to the 2/3. Okay, now this time we have something outside of our radical. So this is similar to one that we had in the last section. So we do not want to put parentheses because that 2 is not included inside our radical. So our 5 is our exponent and our 3 is our index. So we're going to have 2 times x to the 5/3. Okay, so no parentheses there, meaning the only thing that gets the 5/3 would be our x. Okay, so this is a different form of our radical forms. This is the second one. We haven't used this one yet. We do not have an index here, so remember we assume it is a 2. And then we have our exponent on the outside of our parentheses, and it's a 3. So even though it's not inside, it's still considered our exponent. So we would rewrite it as y to the 3/2. Okay, number 5, we have 1 over the square root of x cubed. So let's go ahead and turn that into a rational exponent, and then we'll take care of the fact that it's on the bottom of our fraction, so it's in the denominator. So our exponent is a 3, and our assumed index is 2. So when we change that into our rational exponent, we have 1 over x to the 3/2. Now remember in the beginning, if we had a negative exponent, we would move it to the bottom. Or if we had a negative exponent on the bottom, we'd move it to the top. So whenever we want to take care of it being a fraction, we want to move something, we have to change the sign. So we would have, instead of a positive 3/2, now we have a negative 3/2 as our exponent. And the last section we're going to look at is how to simplify. So simplifying radicals by factoring and grouping. So our first one, we have 64 to the 1/3. Our exponent is a 1 with our index being a 3. Okay, so we are going to take the cube root of 64. Okay, so now we factor. Lots of different ways to factor. The 2 factors I chose were 8 and 8. And then going from there, we have 4 and 2 and 2 and 4, and then factor our 4s into 2 and 2 and 2 and 2. So because our index is a 3, we are looking for groups of 3. We have 2 groups of 3 here, so 2 sets of 2. So for every set we have, we're going to take out one of those numbers. So we're going to take out a 2 for the first pair and a 2 for the second pair. So we have 2 times 2. So 2 times 2 is 4. Now looking at our next example, we have 7 to the 1/2 times 7 to the 1/2. So let's change both of these into radical form first. So anything to the 1/2 power, that is just a square root. So we have the square root of 7 times the square root of 7. Now thinking back to our rules with radicals, as long as they have the same index, we multiply what's outside of the radicals and what's inside our radicals. Now we don't have anything outside, so we need to multiply the inside. So 7 times 7 would give us the square root of 49. The square root of 49 is a perfect square, and we know it is 7. Okay, number 3, we have 5 to the 1/3 times 25 to the 1/3. Okay, so we have a 1 as our exponent and 3's as our indices, okay, our index. So we have the cube root of 5 times the cube root of 25. So again, as long as they have the same index, we can multiply what's underneath. So when we multiply, we get the cube root of 125. Now we need to factor. So I know Two of our factors are 5 and 25, sorry. And then factoring 25 into 5 and 5. Again, our index is a 3, so we're looking for a group of 3. We have one group of 3, so our answer would be a 5. Number 4, we have 3 times x to the 1/2 and then 4 times x to the 3/2, and those are being multiplied. So our 3 and our 4 do not have our rational exponents, so those are going to stay outside of our radicals. So we have 3 times the square root of x times 4 times the square root of x cubed. So we multiply what's outside of our radicals and what's inside. So 3 times 4 gives us a 12. And then x times x to the 3rd gives us our square root of x to the 4th. When we take the square root of x to the 4th, we end up with 12x squared. Number 5, we have another negative exponent. So we have 25 to the negative 2.5. So first we always fix if it's a negative, so we put it over 1 and flip it. So now we have 1 over 25 to the 2.5. Now we still have to change that 2.5 into a fraction. So 2.5 as a fraction is 5/2. So now we need to put it in radical form. So a couple of things to look at here. I know I'm going to be taking the square root. Now I can either raise 25 to the 5th first, using the first form we looked at, or I can raise it to the 5th second at the very end, like our second form. I'm going to do it at the end. Okay, so by doing it at the end, I go ahead and take the square root of 25. Okay, so we all know the square root of 25 is 5. So now I raise 5 to the 5th power. And 5 to the 5th is 3,125. So our answer would be 1 over 3,125. Number 6, we have 32 to the 3/5. Okay, so again, we can either choose to raise it to the 3rd at the very end or do it at the beginning. I'm going to go ahead and do it at the end. So let's go ahead and take the 5th root of 32. Okay, so we need to factor. 32 factors into 4 and 8, 2 and 2, and 2 and 4, and then our 4's factor into 2 and 2. So we are looking for a group of 5. We have one group of 5 here. So when we take that out, we're left with 2, and then we still have to cube it. So 2 cubed gives us 8. In our last example, we have negative 8 times x to the 15th. And then that whole thing is being raised to the 1/3. So since the whole thing is in parentheses, you have to think of it as the 1/3 is going to both the negative 8 and x to the 15th. Okay, so make sure you realize it goes to both. Okay, so we're going to put that whole thing under our cube root. Okay, so when we factor negative 8, we can get negative 2 times negative 2 times negative 2. And then we also have 15 x's. Now we're looking for groups of 3 because we're taking the cube root. So we have one group of 3 for our 2's, and we have 5 groups of 3 for our x's. So when we take all of those out, we have negative 2 times x to the 5th.